Hello and welcome back to Calculus 2. Trigonometric substitution with revenge, right? The previous section is going to be the part of these problems, like the middle part. We are going to get a problem that contains square roots and things like that, convert those into trig functions, use the previous section to solve the trig integral we have, and then at the end convert the trig answers we get back into x answers that we started with. So it's like a three-step procedure, where the step 2 is the previous section. So practicing these problems is bigger gain, right? Because you necessarily practice the previous section along the way anyway. So doing 60 problems of these beats doing anything in the other section, right? So try to do as many of these as you can in practice. Now, where do we begin? We begin with remembering our pre-calc 2, our trig, with the opposite, adjacent, and hypotenuse. We are going to remember that sine theta is opposite. I should have done all of this in red. Sine theta is opposite over hypotenuse, because this is the stuff that if you don't know, you go home. Cosine theta is adjacent over hypotenuse. And tangent theta, these are the only three we need, is opposite over adjacent. In addition to this, I'm going to write on this triangle ABC, and I'm going to write the basic Pythagorean theorem, which says a squared plus b squared is equal to c squared. You know what, I'm gonna just switch the order. C squared is equal to a squared plus b squared. B squared is equal to c squared minus a squared. And a squared is equal to c squared minus b squared. This is the same formula, just flipped 3 times. Are we all okay with that? Hopefully we are, right? And I'm going to ask you to pick up the pattern, because the method that I want to teach is not the method from the book. And if you are able to pick up the pattern here, the method becomes a joke. Look at this. These guys are called legs, and the C is called the hypotenuse. Do you see that anytime you have a minus sign, there is a hypotenuse here? And if it's a plus sign, it's both legs. This is how you're going to know where to assign stuff for the triangle. So that's the key. Now, the best way to teach the entire section is to immediately go into the example, because there is no theory for this one, right? It's just example 1, and we just go right in it. No formulas, nothing. It's just, you need to know this. So let's go and pick up one example. Say we go with integral of, trying to find something that it's not diabolical. How about this? Dx divided by the square root of 16 minus x squared. Now, if you look at your methods that you know so far, clearly not basic, can you do u sub? Basic u sub? And the answer is no, because you are missing an x over here. In order to do the basic u sub, you have to take the derivative of x squared, which will be 2x on top. You don't have the x on top, so you can't do it by parts, and so nothing works. Now, what you notice here is this form of a square root Now look what happens with these formulas here as I take the square root. C becomes the square root of a squared plus b squared. B becomes the square root of c squared minus a squared. And a becomes the c squared minus b squared. So I hope that you are picking up that the form of this is the same as the form of this. There is a number minus a number. Are we all agreeing on that? That is the key to succeed here. Now look, we draw the triangle and we pick our theta in the corner. Now we know what the opposite adjacent, right? Opposite is opposite of the angle, adjacent is touching the angle, and hypotenuse is the longest one, right? That has to be common knowledge in this classroom now, like this second. So what do I have? I have 16. Well, first of all, I have a minus sign. Because I have a minus sign, I am guaranteed that the first value, whether it's 16 or x squared or whatever it is, this thing over here goes on hypotenuse, because C. Do we all make that connection? Right? So if you see a minus sign under the square root, then the first value is c squared, which is why I put 4 in there on the hypotenuse. And the second one, which is x squared, is one of the legs. It doesn't matter which one. You can put here or you can put here. Where do you want it now? Top or bottom?
Top.
Top. Fine. That was the first thing I heard. Top. It doesn't matter. It doesn't matter where you put it. Because this form is good for this one and this one. Right? So what do I do from there? I do the Pythagorean identity in the triangle, and I obtain that this side over here is 16 minus x squared, which always has to match this, obviously. So we assign these by looking at the form of the question and whether it fits the formula with plus or with minus. That's how you assign the basic ones. And the third one will be obtained by Pythagorean theorem. We are almost done. I have two pairs of trig functions. Sorry, I have a pair of trig functions that I can write by combining a variable side with a constant side, which is a 4. So you see how I paired x with a 4, and I paired the square root with a 4 to write my trig functions. This is why you don't have to memorize any cases and any formulas. Because one of your three sides will always be a number. And you will involve that side with the other two. So I have a red trigonometric function that I have to write and a blue trigonometric function that I have to write. And this is happening in 100% of the problems. You get the problem and you have your number either here or you have your number here. Doesn't matter. You're going to have it in one of the two places. So that number is either going to be here or there. That's what it is. So now, looking at my red, I'm using opposite and hypotenuse. Which trigonometric function is opposite and hypotenuse? Sine theta, thank you very much. Sine theta is equal to x over 4. How much is x? 4 sine theta. And how much is dx? Immediately. Because we're going to need it, right? You have to substitute dx as well. So how much is dx?
4 cosine theta.
4 cosine theta? D theta, thank you. Yeah, it's not there for decoration, right? And now I have my blue. What's the blue function with the adjacent and hypotenuse? cosine theta is equal to the square root of 16 minus x squared divided by 4. Plug in! Plug in. Integral, what's dx? 4 cosine theta d theta. What's the square root? Square root is 4 cosine theta. Maybe I should have specified that. Square root is equal to 4 cosine theta, right? When you flip it. Oh, did I pick the nicest problem in the galaxy, right? 4 cancels 4, cosine cancels cosine. All I have to integrate is d theta, which is theta plus c. I have to convert that back into x's. No one cares about theta. So what should I do? Pick any function that is a relationship between x and theta and just apply the inverse. So if you pick the red one, right? So I'll just go with the arrow like this. If you pick the red one, what's theta? When you apply inverse sine to both sides, you get that theta equals, I meant to do this. Theta equals is inverse sine of x over 4. Good effort. So sine inverse of x over 4 plus c, and you're done. Or maybe you picked the cosine. Cosine inverse of square root of 16 minus x squared over 4 plus c. Or you can use the triangle to come up with a secant answer, right? There are 6 equivalent answers with inverse trig functions that are here possible, right? Generally, we just go for the simplest one. But in practice, right, you can go and write all 6 and get the inverse tangent, inverse cosecant, inverse secant, inverse, right? All of them. So, one more quick problem and we're done. I'll post the homework. Yes. How about problem 24? Integral of square root of 9 minus x squared divided by x squared dx. Triangle immediately. Theta. It's a minus sign, which means that 9 is the hypotenuse squared. We have a 3 over there. We put x over here, and then you have your square root of 9 minus x squared using Pythagorean theorem on the bottom. We use pairing towards the constant. The red pair is going to be my sine theta, which is x over 3. Which means that x is equal to 3 sine theta, meaning that dx is equal to 3 cosine theta d theta. The blue pair is cosine theta, square root of 9 minus x squared over 3, which means that the square root of 9 minus x squared is equal to 3 cosine theta. I have things to plug in. Integral. Instead of square root, I have my 3 cosine theta. That's the blue stuff. Divided by x squared. 9 sine squared theta. Right here. You have a single x. The formula for the integral over there has x squared. You are squaring this one into the 9 sine squared theta times dx is 3 cosine theta. So let me write this. So this is your blue square root, this is your red x, and this is your red dx. There we go, color coded. X turned into x squared when you square the thing. All right, does this help? So you just plug things in. Now, 3 times 3 is 9 divided by this is that. So this is cosine squared x over sine squared x dx. Theta's everywhere. Theta, theta, theta. Now what?
Is that tangent squared x?
The other one.
Okay.
Cotangent squared x. Cotangent squared theta d theta. Hello, 8.3. Our previous lecture. We need to integrate this. So this is why I say you practice these problems, because they contain your previous section. So how do I integrate cotangent squared? I turn it into cosecant squared, because I can integrate cosecant squared. It's a basic integral. So this is cotangent square is the cosecant minus 1. The integral of cosecant squared is the negative cotangent squared, very good, negative cotangent squared theta, and integral of negative 1 is negative theta plus c. What? Now we convert back to x and we're done. Now guys, I have my triangle that is up there with the 3, with the x, and with the square root of 9 minus x squared, with theta being here. All I need to do is to read these off of the triangle and we're done. Cotangent is adjacent over hypotenuse. Sorry, adjacent over opposite. Adjacent over opposite. Adjacent over opposite. And that needs to be squared. That's your adjacent over opposite for cotangent, and it needs to be squared. And then we can pick for negative theta, right? For theta, we can just go and do the inverse of the sine. So that's sine inverse of theta over of x over 3. Sorry. Plus c. Apply the square. It will make it into a 9 minus x squared because it kills the square root. There is a negative in front of the thing, and then x, and then minus sine inverse x over 3 plus c. And this minus will flip the order, so it becomes x squared minus 9 over x minus sine inverse x over 3 plus c, and that ends it.
Why didn't you have an x squared in the denominator?
I am having a x squared in the denominator. I have no clue what you're talking about. It's clearly x squared. Look. Thank you.
When you had the, when you flip the x to sine, which equation did you do?
So, at the top of the problem, we have a statement that sine theta is equal to x over 3. So this is obtained at the very beginning of the problem. So now, I need theta. So if I apply sine inverse to both sides, then sine inverse and sine cancel each other out,
you want to
leaving the
itself.
theta,
Okay.
yes, sine inverse of x over 3. That's the reason why we do it. All right, so at this point, I'm going to say, since spring break is next week, right? If you like mathematics and Calc 2, have a wonderful break. I hope you have a wonderful break. If you don't like this stuff, I know you will have a terrible break, because in either case, you will be doing this, right? So if you like it, you'll have a great break. If you don't like it, you'll have an awful break. It's just the way it is. Yes?
You have office hours this Saturday as well as next Saturday?
This Saturday, yes. For next Saturday, I'm still working it out. So we'll have to email on
And
that.
it's 1 to 2 on Saturday?
30. To 30.
Why did you switch the x squared and 9 on the bottom?
Because there was a minus in front. When you apply a minus, it becomes minus 9 plus x, and I swap the spots.
Oh, okay.
Now, there will be a second lecture with another 4 or 5 of these examples when we come back from the break to practice both sections. So this is just the part 1 of this lecture. And we'll have to re-upload the notes.